Hi students, so good morning to everyone and welcome to our new chapter, that is probability. Okay, so I'm going to start the concept of probabilities for your JET, JEE Mains and NDA type of competitive exams, and here we can go through all the concepts of this probability and we can start the class. Okay, and all of you quickly join the class and we are going to start it now. Anyways, we are going to start it at 10:30. I have taken 3 minutes early to join the class because all the students has to join the class. Okay, so quickly tell all the students to join the class so that we can begin the class. Clear? Okay. So in this probability chapter, you have to first understand the concepts very much clearly. If you understand the concepts clearly, if you know the definitions clearly, if you know the concepts and their analysis clearly, then only you can understand the chapter, that is probability. So here conceptual clarity is more important. Your logical thinking with your conceptual clarity will give you a very interest in probability. Okay, so for that we can go through the concepts one by one. So first I will start with the fundamental of probability. Next I will go for the probability. Okay, the fundamentals of probability is very important, because if you know the fundamentals clearly, then you can go for your concept and you can understand the problems. Okay, so good morning to everyone. Let us begin the class and start to understand the concepts. Okay, so first I will go with the fundamentals of probability. In this fundamentals of probability, first we shall go with the basic definitions. Clear? So in this basic definition, first you must understand what is experiment. Okay, so my dear students, experiment means, for example, if you take any tossing the coin, rolling the dice, picking the card from the deck of cards, these all are called experiments. That means an operation which results in some well-defined outcomes is called experiment. You just say this: an operation in which results in some well-defined outcomes. Well-defined outcomes is called an experiment. So by looking at this, I think you may go through or you may remember one definition previously that you have studied in the other chapter. Can you tell me what is that chapter? Already you have studied this well-defined word in the another chapter. Can you remember that chapter? What is that chapter? In the sets we learn as what? In the sets we learn it as collection of well-defined objects. The sets we are going to learn it as a collection of well-defined objects. Okay, or well-defined elements. That is called set, that we learn in the sets topic. Okay, in the same way here experiment means an operation which results some well-defined outcomes. Some well-defined outcomes is called experiment. That means the sets topic and the probability topic is very much interrelated. How much good you understand the sets topic, that much nicely you can understand the probability topic. Okay, so all the properties of the sets, all the definition of the sets we are going to apply on our probability concepts. Okay, so that's why here you must know the sets topic very much neatly, or the concepts of the sets must be very much clear. Okay, so that means you can directly go for your probability topic. Okay, so here experiment means it is an operation which results some well-defined outcomes. A well-defined outcomes is called an experiment. So that you can see, for example, probability of coin. That means coin experiment. See, when I toss a coin, you are not in correct status that it is going to be in a head or it is going to be in a tail. You are not in a clear. Okay. So when the experiment get complete, you are going to get an idea. Yes, this occurs head or this occurred tail. Okay. But here this experiment is going to be a random experiment. Okay. The outcomes are not predictable. The outcomes are not predictable, but the outcomes are definitely going to be well defined. The outcomes are definitely going to be well defined. Okay. So here tossing a coin is an experiment whose outcomes are well defined. Clear? So you can take an example that tossing a coin as an one of the example for your experiment definition. Okay. So now I think all of you understood what is experiment. Experiment means it is an operation which is giving a well-defined outcomes. Is called an experiment. Next, random experiment. Random experiment means the outcomes cannot be predicted. Please understand this. Random experiment means in which the outcomes cannot be predicted is called random experiment. Clear? So that's why random experiment is going to say that whenever the experiment is going to be done, the outputs of the experiment are not going to be predictable, and certainly it is called random experiment. Okay, so that you can go through it. See the definition: an experiment whose outcomes cannot be predicted, whose outcomes cannot be predicted with certainty is called a random experiment. Is called a random experiment. In other words, if an experiment is performed many times under a similar conditions and the outcomes of each is not same, then the experiment is called random experiment. Okay, so random experiment means the experiment through which where the outcomes are not going to be predicted. The outcomes are not going to be predicted is called random experiment, or also you can say the experiments which are done repeatedly. But not getting the same outputs. Okay. For example, you can take here throwing an unbiased dice. So all of you know that dice has 6 faces. So whenever you go through the rolling of dice, the all outcomes are always not predicted. It may be 1, it may be 2, it may be 3, it may be 4, it may be 5, or it may be 6. But you can't predict 2 will occur. You can't predict the 3 is going to occur. Okay, that prediction is not possible. Clear? On the same way, you throw the dice for as many as times. You throw the dice for as many as times. The outcomes will be not same every time. If 1 occurs now, there are the chances of occurring other than 1 in the second throw, other than 2 in the second throw. If you get 2 on this first throw, the same thing will not appear in the second throw. The same thing will not appear in the third throw. Are you getting my point? So when I roll a dice for first time, you may get 2. For the next time, you may get other than 2. that means you may get 3, you may get 4. Okay, once you get 4, for the next time again you are not going to get 4. That means the outcomes are not repeated. Outcomes are not going to be the same terms. Outcomes are not going to be the same terms. So such type of experiments are called as your random experiments. Okay, so first thing, one thing you remember, random experiment means the outcomes are not predicted. The outcomes are not predicted. Okay, and one more thing, if you do this experiment repeatedly, the outcomes will be not same. The outcomes will be not same. Okay, so in that cases we say the experiment is random experiment. Clear? So try to understand the concepts. Don't by heart the definitions. Please try to understand the concepts, because whenever you go for JEE Mains, NDA or your KCET exams, here the conceptual clarity is very, very important. So please go through the conceptual clarities. Please don't try to by heart the definitions. Okay. Now I will go for one of the example. See what was I explaining. That is tossing a dice. Tossing a dice. Consider the simple experiment of tossing a dice, observing the number on the upper face. Observing the number on the upper face. Okay. So you can get 1, you can get 2, you can get 3, you can get 4. On the same way you can get 6. Okay. There is 6 basic possible outcomes of a random experiment. Okay. Because dice has 6 faces, so there will be an possible cases of 6 outcomes. There will be an possible cases of 6 outcomes when you roll a dice. Okay. That's why we say rolling a dice or tossing a dice is a random experiment. Clear? Okay. So next we go for sample spaces. See, first we studied experiment. Next we gone for random experiment. Now we are studying sample space. What happens here? You just see. First you must know experiment. First you must know experiment. What is experiment? Experiment is that where the outcomes are well defined. Experiment is that where the outcomes are well defined. Okay. After the experiment, we study random experiment. After the experiment, we go for random experiment. What is random experiment? Random experiment is where the outputs are not predicted. Where the outputs are not predicted. Experiment means the outcomes are well defined, but random experiment means the outcomes are not going to be predicted. Okay, so that is random experiment. Now we are studying sample space. Now we are studying sample space. That means the outcomes of random experiment. The outcomes of random experiment are called sample space. Are you getting my point? The outcomes of random experiment means what? That you can see. For example, if I take a coin and if I toss it. If I take a coin and if I toss it, what you are going to get? You may get head, head, you may get head, tail, you may get tail, head, and you may get tail, tail. That means when I toss a coin, you have a choice of it may occur with head, head, it may occur with head, tail, it may occur with tail, head, and it may occur with tail, tail. Are you getting my point? So this is called sample space, or these outcomes are called as the sample space of the random experiment tossing a coin for 2 times. Tossing a coin for 2 times. Okay. So those things are called the sample spaces. Those things are called as the sample spaces. Okay. So these are the outcomes of the coin tossed for 2 times. The coin tossed for 2 times. So these outcomes are called as the sample spaces. Okay. So most of the students are not live. Why they are not live, I don't know. And I also given the message before half an hour, 30 minutes before I have given the message, but still so many of you are not on the live class. Let it be, it's their choice, we can't do anything. Okay, so head tail, tail head, and tail are going to be the number of outcomes from the random experiment of tossing a coin for 2 times, clear? So that you can see here one very important note, that is 2 to the power of n. 2 to the power of n is going to be the formula for finding the total number of the space for tossing a coin, where n is the number of tosses, okay, clear? That means if you toss for 2 times, it will be 2 to the power of 2, 4 number of sample spaces will be there. If I toss for 3 times, 8 number of sample spaces will be there. If I toss for 4 times, 16 sample spaces will be there, like that. That means the formula for the number of tosses of a coin is 2 to the power of n, okay? So if you toss for 1 time, 2 to the power of 1 is going to be 2, clear? That means the outcomes are 2. That means the outcomes are 2, okay? So please remember, very important formula, that is 2 to the power of n. 2 to the power of n means total number of outcomes, total number of tossing a coin. Tossing a coin is equal to 2 to the power of n, where n is the number of tosses, okay? That means if I toss a coin for 3 times, 2 to the power of 3, 8, you are going to get 8 sample spaces. If I toss a coin for 2 times, you are going to get 4 sample spaces. Are you getting my point? So these things you have to remember. That means the sample space means it is the total possible outcomes of a random experiment. The sample space means the set of all possible outcomes of a random experiment is called the sample space. The possible outcomes of a random experiment is called sample space for that experiment. And it is usually denoted by capital letter S. Okay. So already we have discussed, when a coin tossed for 2 times, head tail, tail head, and tail are going to be the sample spaces, clear? So I think you have understood about the sample space. Now we can go for the sample point or event point. Sample point or event point means, say, by tossing a coin for 2 times, what we got? We got head tail, tail head, and tail. So these are the total outcomes of the sample. These are the total outcomes of tossing a coin for 2 times. That means each head tail, tail head, and tail are called as sample point. Here head is called sample point, first sample point. Head tail is called as second sample point, okay? And next tail head is called third sample point, okay? And next tail is called as fourth sample point, okay? So these are called as the sample points. These are called as the sample points of the random experiment when the coin is tossed for 2 times. Okay, so the elements of the sample space, the objects of the sample space are called as sample point, or we can say it as an event point, sample point, or we can also call it as an event point. Okay, so these things are going to be really very important. So that's why please go through it, and you have to understand those things. Okay, so please understand them. Give me 1 minute of time because I have one work to do. Okay, so you can see that okay students. So what I was explaining about sample point and event point. The elements or the objects which are present in the sample space are called as sample point or an event point. Sample point or an event point. Clear? So here we can see head, tail, head, and tail are going to be the sample points, or we can also call them as an event points. Okay, so here you can just go through it, no problem, that you can understand. Each element of a sample space, are called as an sample point or an event point. That is what we were explaining. Okay, so here you can just see S is equal to 1 2 3 4 5 6. That means the sample space of a dice is thrown. When the sample space of a dice, when the dice is thrown, or when the dice is tossed, you have 6 choice. First one is 1 2 3 4 5 and 6, where 1 2 3 4 5 and 6 are the sample points, are called as a sample points. Clear? On the same way, when the coin is tossed for one time, what are the sample space, what are the sample points? H and T. This is called sample space. Set of H comma T is called as sample space. The elements present in the sample space, head, tail, are called as sample points or event points. Okay, so these things are called as sample points or an event points. Clear? On the same way, when the card, when you okay students, so because of some inconvenience we lost the connectivity. No problem, we are again back live. Okay, no problem, we are again back to live class. No problem, let us continue with our concepts. Sometimes it happens if the time is not good. No problem, now we are back again live. We can continue our class, and all of you quickly join again. All of you quickly join again to the class so that we can continue. Okay. Okay. So quickly join to the class. We can continue it. No problem. Sometime it happens. No worries. Okay. So we were looking about sample point and event point. Sample point and event point. Okay. So what is sample point and what is event point? So I think all of you now understood what is event point and sample point. Clear? Sample point or an event point means it is an element of your sample space. It is an element of your sample space. Okay. So here you must have an idea about what is sample space, what is experiment, what is random experiment, what is sample space, and then you come for sample point. See, the concepts are very much interrelated. Don't miss. Okay. That is, first one is you go for experiment. First you study about experiment. Next you study about random experiment. Okay. First what we studied? First we studied experiment. Next we studied random experiment. Next we studied random experiment. And next we studied sample space. Next we studied sample space, and now we are studying sample point or an sample event. Sample point or an event point. Okay. So no problem. These things all are very much interrelated. If experiment is done, then only the random experiments are possible. If random experiment is done, the outputs are called as sample space. If you have sample space, the elements of the sample space are called an sample event or sample point, or you can say it as event point. So for this all, only one thing is important, that is experiment. Okay. Without experiment, you can't get sample space. Without sample space, you can't get sample point. So that's why these all things are very much interrelated. So these all things are very much important for our probability concept. So please understand them. Okay. Club. This is called club. This is heart. This is spade. And this is diamond. Okay. So like this, you are going to have four different suits. In that each suit, you are going to have 13 cards. This is called diamond. Okay. So now you can just see, this is the set of club, this is the set of spade, this is the set of heart, and this is the set of diamond. Okay. So in each set there will be 13 cards. In each set there will be 13 cards, and you are going to have four face cards. One is ace, another one is jack, another one is queen, and another one is king. Okay. So you are going to have four face cards that you can just see here. You are going to have four face cards, that is ace, jack, queen, and king. Clear? So you are going to have four face cards, and in each suit you are going to have 13 cards. Okay. In that there will be four face cards. Are you getting my point? So total 52 cards you are going to have. So you can say that each card is event, that is event point. Each card is event point. See here, you have 52 event points. You have 52 event points. Clear? Because you got 52 cards. In the deck of card, you got 52 cards. So each card is called as an event point or an sample point, you can say. Clear? So the sample point or event point means it is an element of sample space. Clear? Okay. Next we shall go for event. Next we shall go for event. Very, very important. See, an event is associated with subset of sample space. Please understand this. Event means it is in a subset of sample space. For example, you just see here, if I toss a coin for one time, what will be my sample space? Sample space is going to be head comma tail. Sample space is going to be head comma tail. So here event E1 I can write H. Event E2 I can write it as tail. Why? Because events means these are the subsets of sample space. Events means these are the subsets of sample space. Are you getting my point? You can say E1 is subset of sample space yes. E2 is event subset of sample space yes. Are you getting my point? So therefore, occurrence of head, occurrence of tail, if we write separately in two different sets, they are called as what? Events. They are called as events. Are you getting my point? So total in the sample space you have head comma tail. Event E1 is occurrence of head. Event E2 is occurrence of tail. E1 is subset of sample space and event E2 is also a subset of sample space. That means event means it is in a subset of sample space. Event means it is in a subset of sample space. Okay. So now event is associated with the subset of sample space. Events can be classified into two types on the basis of elements they have. So they are, you can see, impossible events or sure events. Impossible events and sure events. You can tell them that impossible, the events are of two types. One is impossible event and another one is sure event. That means impossible means the event is empty. Suppose if I take here, see, I will take event E3 as occurrence of head for 2 times when that coin is tossed for once. Please see, my event is E3 occurrence of 2 heads. Occurrence of 2 heads is impossible event because the coin is tossed only once. The coin is tossed only once. Either it go with head or it go with tail. Either it go with head or it go with tail. No 2 heads is possible when a coin is tossed for one time. So that's why event E3 is impossible. Event E3 is impossible event, and here E3 is going to be equal to empty set. Here event E3 is going to be equal to empty set. Okay, so have you understood this? Have you understood this? What is impossible event? Sure event means definitely that event is going to occur. Sure event means definitely that event is going to occur. For example, you can take E1 and E2. E1 is what? E1 is occurrence of head. So this is sure event. Definitely head is going to occur. So that's why we say event E1 is sure event. Event E3 is impossible event. Event E3 is impossible event. And event E2 is, I can say, occurrence of tail. Occurrence of tail. This is also sure event. This is also sure event. Definitely that event is going to occur. Okay. So in events you have 2 types. One is impossible event. Another one is sure event. Impossible event means that event will not occur. Sure event means that event definitely going to occur. That event definitely going to occur. Okay. So next you can say simple event. Next one is simple event. Simple event means only one sample space will occur once. Okay, that means you can say, see here, one sample space is going to be possible. Clear? For example, if I throw a coin once, you are going to get head. Okay, and if you throw 2 times, you are going to get head for 2 times. Are you getting my point? So that's why if you say, if I throw in a coin twice, you are going to get head 2 times. Clear? So simple event means if an event E has only one sample point. Event E has only one sample point. Event E has only one sample point. See this, only one sample point of a sample space. It is called a simple event. Simple event means only one sample point must be present. Only one sample point must be present. That type of event is called your sample. That type of event is called simple event. For example, you say by tossing a coin for 2 times. Tossing a coin for 2 times and getting 2 heads Okay, tossing a coin for 2 times and getting 2 heads. That means it is possible only with event E equal to h comma h. Okay, so here you are going to have only one sample space. So that is called as your simple event. That is called as your simple event. Are you getting my point? Simple event means in your sample space there must be only one sample point. That is called simple event. That is called simple event. Have you got my point? Next, compound event means more than one sample point. If a sample space consists more than one sample point, it is called compound event. For example, you can just see one example here. I have taken it as tossing a coin, an experiment of tossing a coin thrice. The events, exactly one head appeared. See, exactly one head appeared. 1, 2, 3. You have 3 sample points. So that's why it is called compound event. Next, you can see at least one head appeared. At least one head appeared means you can see this. At least one head appeared. You have how many sample points? 1, 2, 3, 4, 5, 6, 7 sample points. So if you have more than one sample point, then we call it as a compound event. But my dear students, here you have to understand one very important thing. At least one head. At least one head means minimum one head. Minimum one head. More than one, not more than one, you can take, no problem. At least one means C H comma TT. You have one head. You can also write T H T. Here also you have one head. T T H. Here also you have one head. Are you getting my point? On the same way, you can write triple H. Here 3 heads are possible. Okay. On the same way, you can write H H T. On the same way, H T H. On the same way, T H H. These all are possible cases because they are asking minimum one head. At least means minimum one head must be present. If 3 are there, no problem. 2 are there, no problem. 2 are there, no problem. 2 are there, no problem. Okay. That means you must have minimum one head in that. That is the meaning of at least one head. At most, see this, at most one head. At most one head means maximum you can get one head, not more than that. At most one head means maximum one head, not more than that. Then you have head, tail, 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 head, tail, 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 head. Only 3 possible. On one more you can see at most one head. Okay, at most one head means these are the possible cases. Clear? These are the possible cases. And one more you can say tail, tail, tail. At most one head means maximum one head. Here no heads, no problem. What they are telling, maximum one head you must get. If no heads, no problem. If no heads, no problem. Are you getting my point? So at least means minimum one, maximum anything. At most one means one head, minimum you make 0. Okay, at most means it starts with 1, minimum value 0. At least means it starts with 1, maximum anything. Are you getting my point? So at most means you should come lower side, at maximum, at least means you must go upper side. Are you getting my point? At most means that is the maximum. You have to keep 1 as the maximum, you have to come for 0. At least means you have to keep that as the minimum, 1. You can go for maximum, more than 1. Okay, so that is called at most and at least. Are you getting my point? So at most means one head, no heads, no problem. So you have 4 sample points. You have 4 sample points. Clear? Here you have 7 sample points. These are called as your compound events. These are called as your compound events. So compound event means which has more than one sample space, which has more than one sample point is called compound event. Okay, simple event means the sample point must be only one. The sample point must be only one. Okay, so next we have to go for algebra of events. So in the algebra of events, first one is complementary event. Complementary event. Already you know what is complement set. Complement set is given by a dash, a to the power of c, or a like this. So these are the notations of complement of set. So complementary set means the elements which are not present in that set. Same way, complementary event. Okay, you can just go through the complementary event. That is, for every event A, there corresponds another event A dash or a to the power of c or a dash is called complementary event to A. It is also called the event not A. It is also called event not A. Same like in complement set. In complement set, what you say? The elements which are not present in that set. In the same way here also, the event which is not A. The event which is not A is called as complementary event. Okay. For example, you can take sample space, 3 heads, head, tail, head, so on to tail. Be a sample space and let A is head, tail, 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 head. Okay. Be a subset of yes. Now, complementary of A means in that complementary set, these things will be not present. The set A will be not present. That is called complementary event. So in the sample space you have these elements. Now in the A dash, these 3 elements must not present. Leave these 3 elements, write the remaining elements, that is head, tail, head, tail, head, and tail. Don't write your set A. Okay, so you don't write this. Are you getting my point? So if you don't write this, that will be your A complement. That is your complementary event. Are you getting my point? Complementary event means in that event you are not going to be present with the elements which are present in A. Okay, that is called a complementary event. Clear? Okay, so next you can just see event A or B. Event A or B means it is union. As we studied in sets, event A or B means this is union. Clear? in a set of it is a set of all those elements. It is a set of all those elements which are either in A or B, either in A or B, or in both, and it is denoted by A union B. It is nothing but as your union of two sets. It is nothing but as your union of two sets. That is called event A or event B. Already you know what is A, B. A union B is 1, 2, 3, 4. Okay. So all of you know this, no problem. We can go for the next, that is event A and B. Event A and B means intersection. Okay, that is the intersection of two events. You can see the example 2, 3, 5, 1, 2, 3, 4, 5. 2, 3, 5 is your intersection. 2, 3, 5 is your intersection of two events. Okay. So next, event A but not B, the difference of two sets, what we have studied in the set theory, the difference of two sets, the elements present in A but not in B, that is what A minus B, and we can also write it as A intersection B complement. Okay, that is called event A but not B. We have studied in the set theory, or we have studied in the set chapter, that is X belongs to A but not for B. That means X belongs to A but X not belongs to B. That is your A minus B. Okay. So this is your event A but not B. Clear? So you can see the example A equal to 1, 2, 3, 4. Event B equal to 1, 3. So A minus B means elements which are in A and B, leave it 2, 4. So 2, 4 will be the answer. Okay. That is elements which are in A but not in B. Elements which are in A but not in B. Okay. So now we can go for the next set. Next we can go for the next set, that is some are important events. See, there are some important events which you have to always be careful regarding this. So be careful regarding some important events. Be careful regarding some important events. Very, very important. They are called as, first one, equally likely event. Equally likely event means you just see, if I roll a dice, I will roll a dice and see what will be the sample spaces. 1, 2, 3, 4, 5 and 6. Each sample point has got equally possible. Each sample point is equally possible. Are you getting my point? So when I roll the dice, there is an equal chance for all 6 sample points. There is an equal chance for all 6 sample points. That is called equally likely event. Are you getting my point? Equally likely event means all the sample points must have this equal possible chances. The occurrence of equal possible chances is called your equally likely event. Are you getting my point? So if I roll a dice, there is an equal chance for all 6 faces. There is an equal chance for all 6 faces. So that's why that is called as equally likely event. Okay. So now I will go for, say this, exhaustive events. Very, very important. My dear students, you must understand what is exhaustive and what is exclusive. So if you want to understand what is exhaustive and if you want to understand what is exclusive, first let us go for exhaustive. My dear students, exhaustive means you just see, I will give one example. This I have event E1, event E2, event E3, event E4, so on to event En. When I make the union of all this, when I make the union of all event E1, event E2, event E3, so please understand this. If I take event E1, event E2, event E3, so on to event En, I have n events. I have n events, and now what I want to do, if I make the union, if I make the union of all those events, if I make the union of all those events, you must get your sample space. You must get your sample space. Please understand. This is also very important. See this. If I take the intersection of any two events, if I take intersection of any two events, it should be equal to empty. It should be equal to empty. This type of events are called as exhaustive events. This type of events are called exhaustive events. Please understand this, very, very important. Okay. See this. For example, I have, first let us understand this. First condition, E1 union, E2 union, E3 so on to union with En must give your complete sample space. Must give you complete sample space. Then I say this is what? Exhaustive. And the second case is what? And the second case is intersection of any two events must be equal to empty. Intersection of any two events must be equal to empty. That means if I take rolling a dice, I will roll a dice and the sample spaces are 1, 2, 3, 4, 5 and 6. So when I roll a dice, I have 6 sample points. 6 sample points, and my sample space is 1, 2, 3, 4, 5 and 6. Event E1, I will write the occurrence of even numbers. Occurrence of even numbers. Occurrence of even numbers. Next, event E2, I will write 1, 3, 5. Occurrence of what? Odd numbers. Occurrence of odd numbers. Okay. So now you can just see that. If I make union of both of the events, I will get complete sample space. I will get complete sample space. Are you getting my point? But the intersection of E1 and E2 is always equal to empty. The intersection of event E1 and event E2 are always equal to empty. Okay. So that is called, so here, see this. This is called, occurrence of odd numbers. This is called occurrence of even numbers. Are you getting my point? Clear? So if I get this, it is called mutually exclusive. It is called mutually exclusive. And this is called mutually this is called mutually exhaustive. This is called mutually exhaustive. And the second one is called mutually exclusive. Mutually exclusive. Okay. So here first you understand very, very important thing, that is there are two cases. First one is when you make the union of all the events, you must get the complete sample space. That is called mutually exhaustive. And the second one, if the intersection is empty, then we say it is exclusive. This is called exclusive. Second case is called exclusive. And the first case is called exhaustive. Okay. So here you can just see by taking the sample space, yes, 1, 2, 3, 4, 5, 6. Event E1 I will take 2, 4, 6. Event E2 I will take 1, 3, 5. Okay. So now if I take event E1 and E2 and if I make union of this, what I will get? 1, 2, 3, 4, 5, 6. So you can say E1 and E2 are mutually exhaustive. Okay. So if I make the union of all the events, we must get the sample space. We must get the complete sample space. Then we say that is mutually exhaustive. Okay. And next one you can see, this is the exhaustive case. That is probability of A union B must be equal to 1. Please remember, probability of A union B must be equal to 1. Clear? There are no elements outside the two events. That means here, for example, all the events must be in your set. Here there must be no elements. All the events must be in your set. Okay. So outside the set there must be no any elements. That is called exhaustive. Clear? Exclusive means you can just see two disjoint sets. Previously we have seen here the intersection must be empty. Is called exclusive. Okay. So if the intersection is empty, that means if two events are disjoint, we say that those things are mutually exclusive. Clear? You can also see mutually exclusive means the disjoint events are called mutually exclusive. Are you getting my point? So let us take one example. So here I will take one example so that you can understand what is mutually exclusive and mutually exhaustive. See this example. When a dice is thrown, the sample space is 1, 2, 3, 4, 5, 6. So this is sample space. Okay. Now we are going through what is mutually exclusive and mutually exhaustive. First I have taken sample space. Next, event A is greater than 4. What you are going to get? 5, 6. Event A is greater than 4. It will be 5, 6. Next, event B is occurrence of odd numbers. That is B, 1, 3, 5. C, event occurrence of even number, 2, 4, 6. Okay. So you have 3 events. 1 is A, 2 is B, 3 is C. A, B, C are the 3 events. Now you can see B and C are mutually exclusive. You can see B and C. B is 1, 3, 5. C is 2, 4, 6. If I make intersection, it is empty. Therefore, it is called mutually exclusive. Okay. And next, A and C are not mutually exclusive. A and C, you take A, 5, 6, C, 2, 4, 6. If you make an intersection, you will get what? 6. If you make an intersection, you are going to get 6, because in the set A you have 5, 6, In the set C, you have 2, 4, 6. If you make an intersection, you will get singleton 6. You will get singleton 6. That means intersection is not empty. So that's why they are called not mutually exclusive. That's why they are not mutually exclusive. Are you getting my point? So now please understand one very important thing. One very important thing, that is mutually exhaustive. Mutually exhaustive means E1 union E2 union E3 so on to union En must give total sample space. Total sample space. The second one, mutually exclusive. Mutually exclusive. Mutually exclusive means, see, intersection must be empty. Intersection must be empty. If I take two events and if I do the intersection, it must be empty. If I take n events and if I make the union of that, if I get sample space, that is mutually exhaustive. Are you getting my point? Mutually exhaustive means the union must give sample space. Exclusive means intersection must be empty. Intersection must be empty. Are you getting my point? So you understand this simple thing. That will be very easy to understand. That will be very easy to understand. Okay. So if we say the intersection is empty, that is mutually exclusive. If we say union is equal to sample space, that is exhaustive. Clear? So I think from this you can understand what is mutually exclusive and mutually exhaustive. Now let us start probability. Now we can start what is probability. Okay. And conditions of probability. So see, probability means total number of cases and you will have total number of favorable cases. Number of favorable cases. Number of favorable cases divided by total number of the cases will give you probability of E. Probability of E. Okay, Pavitra Kumbar is asking one question. Sir, A, B and C are mutually exclusive. Sir, in previous example. See, understand one thing. Understand one thing. The event can be both mutually exclusive and mutually exhaustive also. Mutually exclusive and mutually exhaustive also. Please understand this. The same event can be both mutually exclusive as well as mutually exhaustive. For example, we have taken previously 1, 3, 5. E2 as 2, 4, 6. See here, E1 intersection E2 is empty. E1 intersection E2 is empty. Okay. Clear? So for this, what we say, they are mutually exclusive. But we also see that E1 union E2, which gives the complete sample space, that is S equal to 1, 2, 3, 4, 5, 6. That means it gives the complete sample space also. So you can see that E1 and E2 are both mutually exclusive as well as mutually exhaustive. Mutually exclusive as well as mutually exhaustive. Are you getting my point? The same events E1 and E2 can be both. They can be both mutually exclusive as well as mutually exhaustive. But please note one point. Exclusive means union must be sample space. Sorry, exhaustive means union must be sample space. Exclusive means intersection must be empty. Intersection must be empty. Okay, so now I think you got my point. So let us go for the next concepts. Okay. Probability, total number of favorable cases divided by total number of cases. This is known to everyone. Total number of favorable cases divided by total number of cases. No problem. Here, this is important. E dash means complementary event. E dash means complementary event. Okay. So probability of the complementary event will be always 1 minus P of E. Please remember, the probability of complementary event is always going to be probability of E dash is equal to 1 minus probability of the event E. And next, this thing, probability is always in between 0 to 1. Probability is always in between 0 to 1. Okay. Are you getting my point? Please understand this. Probability is always in between 0 to 1. Probability is always in between 0 to 1. Probability of E equal to 1, then the event E is known as certain event. Then the event E is known as certain event. If you get probability of E as 1, it is known as certain event. And if the probability of E is 0, then it is called as impossible event. If the probability of E is equal to 0, it is called impossible event. If the probability of E is 1, then it is called certain event. Impossible event. Please understand these things. Okay. Probability is always in between. Probability is always in between. Greater than or equal to 0. Lesser than or equal to 1, and probability of the complementary event is 1 minus probability of E. Certain event means probability of E is 1, and impossible event means probability of E is 0. Okay, so these all things are very, very important, so please go through it, and in the next class we can continue with the next concepts. And in the next class, we can continue with the next concepts. My dear students, very, very important is 1. See this. Very, very important. Please go through it. Very, very important. Okay. Exhaustive and exclusive events are very, very important. Please go through the definitions, understand them. If you don't get, comment in the comment box. And in the next class, we can again explain about exclusive and exhaustive. And in the next class, I will go for the problems. Okay. In the next class, I will go for the problems. So that is tomorrow at 10:30. Tomorrow at 10:30. Okay. So thank you everyone. Let us meet. And anyways, in the evening also I am going to have one class. I will see what I has to take. Before 4 o'clock, I will share what I am going to take. So let us see what happens in the evening class. Clear? See. When we say mutually exclusive event means, if the intersection is empty. When we say exhaustive means, whenever if you take the union of all the events, you get the complete sample space. Okay. When you take the union of all the events, it will give you sample space. That is mutually exhaustive. Exclusive means intersection is empty. That time we say it is exclusive. If it is both, we say it is both mutually exclusive and exhaustive. So I think Shivanand Meti got his answer. So we can continue in the next class. About the evening class, before I think we take at 5 p.m. right? So before 5 p.m. I will share the thumbnail. So according to that we shall go. Shall we take other than entertaining event, or shall we go through the class? I will see. So today it is Sunday, so weekend, so all want to entertain themselves. So that's why we go for some entertainment session. Okay. Yes. Intersection means, you just see here. Intersection is empty, it is called exclusive. Intersection is empty, it is called exclusive. Union is called exhaustive. Union is called exhaustive. Intersection is called exclusive. Union is called exhaustive. Intersection is called exclusive. Okay. So I think you understood this. No problem. We can meet in the evening 5 o'clock session. So there I will share the link before 1 hour so that we can go through it. Okay.